Hello everyone and welcome back to this next lecture. So as already stated in the beginning of this section, the goal of this section is to introduce pulse width modulation, and this pulse width modulation is the preferred method of providing gating signals to power devices in any power converter. Of course, there may be other strategies as well, but in this course mainly we are talking about pulse width modulation. And towards the end of this section, we will talk about how pulse width modulation is used in a buck converter. But before we get to that, I would like to rather introduce modulation not directly in power electronics, but rather use the domain of communications and signal processing instead. And it is my opinion that it is actually easier to understand modulation in this context, that is in the context of communications and signal processing rather than power electronics. Now, one reason for this is due to the fact that signal processing courses and maybe even communication courses are usually taught before power electronic courses in electrical engineering. So an electrical engineering student, or at least an undergraduate, is exposed to signal processing before power electronics. The next reason is that nowadays almost everyone has exposure to mobile devices. Either we have mobile phones or we have other kind of mobile devices like tablets and laptops. So therefore communication is something that almost all of us are aware of to some extent. Even though the details we may not understand, we do understand most of how communication takes place. So therefore it is usually easier to understand modulation in terms of communications and signal processing. Now, it is important to understand that at a fundamental level, modulation is merely a process by which two signals are mixed together. And the idea behind this mixing is to produce another signal. And this other signal usually has some properties which make certain processes easier. And these processes could be, for example, transmission of the signal over long distances. This usually happens in communications. In power electronics, however, we don't need to transmit it, but we need to do something else, and we'll talk about that very soon. So, in the domain of communications, as I already said, the major problem or challenge is to be able to transmit an audio signal over long distances. So, for example, let's take the case of mobile communications. So, we are two people talking to each other using their mobiles. Of course, we can also have more of them, especially nowadays when you have WhatsApp and you have group calls. But let's take the simple case of just two people talking on their mobile phones. Now, these people could be in the same building, so they could be even 100 meters apart, or they could be several thousands of kilometers apart if they're actually living in two different countries. Right? Now, how does this actually happen? Let's just go through this process. Now, when you talk into your mobile phone records your speech and converts it into a signal. Alright, that's usually how it happens. Now, I won't go into the detail of how that takes place because we don't need that many details. You just need to know that there is a signal that represents your conversation, your speech. Right? For example, now I'm recording my course. I'm speaking to a microphone. The microphone picks up my speech, converts it into a signal. Right? And eventually that is a signal that you're listening to. Now, this signal, because it is my voice or because it is any human's voice, it'll have a varying amplitude and also a varying frequency, right? Why? Because even like for example, my voice is continuously rising and falling. So therefore there will be a varying amplitude. In terms of frequency, every human has a frequency, right? Some people have deep voices, some people have squeaky voices. A child will have a different frequency because a child always speaks in a different frequency, right? So depending on the frequency, the signal will also change, or rather depending on the person and also the words which are being spoken and the languages is being spoken, the signal will have a different frequency. Now, just to give you a ballpark number, humans usually speak in frequencies around 300 Hz, between 100 Hz and 300 Hz, right? So, now, this 300 Hz, if you take a frequency range of 100 Hz to 300 Hz, this is considered to be low frequency, right? So therefore, the signal representing the human conversation can be said to be a low frequency signal that could have a very low amplitude, because we are talking about the worst case. The best case is people are speaking very loudly, but in reality that may not be the case, right? You may be speaking quite softly. Now the challenge here is we need to take this signal, this potentially weak and variable signal, right? So not only is it variable, it is also potentially quite weak. And this signal needs to be transmitted by the mobile phone to communication towers. So for example, the mobile phone is going to transmit it to a communication tower. There may be a series of communication towers. Again, I do not know much about communication, so I'm just giving an example. And finally, the last communication tower might end up transmitting it to a communication satellite. This is how it happens. So now all this communication, this time, every time the signal passes through all these communication towers and through this distance, it's going to keep getting weaker and weaker. Why? Because as you transmit the signal, there are going to be losses. It's wireless transmission, right? The air is going to absorb some of that energy. If we transmit the signal as it is, right? If the signal corresponding to the transmission is transmitted as it is, without any modifications, the result is, as we transmit it, by the time it reaches the other person, it's going to be complete garbage. It's going to be completely dissipated. So which means the other person will not understand anything if you just transmit the signal as it is. And it is for this reason that now we have to process it. And this processing means that we need to take the signal from the conversation and we need to mix it with another signal. Now we have no control over the conversation because that's how speech is done, right? The human will speak in whatever way he wants. So there is no control over this. But we can take another signal that we do have control over. Now this other signal can be very tightly regulated with respect to amplitude and frequency. We have no control over the frequency of the human conversation, but we can control the amplitude of this other signal. We can also control the frequency of this other signal. So we can pick specific frequencies and amplitudes and we can control it the way we want. Now, this process of mixing these two signals is called modulation, right? And there are many ways in which we can mix these two signals. We'll talk about a couple of major modulation processes very soon. Now, the result of the modulation process will also vary as the process varies. Quite obviously, if you're going to mix it in different ways, you end up getting different results. But we can make a couple of inferences even though the process may change. The result of this modulation process is usually a high frequency signal. And this high frequency signal will have several components, will have several frequency components. And somewhere in those frequency components will be the audio signal, right? Again, I'm only going into the basic concept, the abstract concept. I'm not talking about the details yet. The details will come very soon. But this, by mixing our audio signal with this other high frequency signal, you are producing another high frequency signal. And this other high frequency signal has hidden in it somewhere, don't worry how, somewhere the audio signal in some form, right? The result is that because we now have a high frequency signal as a result of this modulation process, this high frequency signal, we can control the amplitude and the frequency. So right, because we have taken another signal whose amplitude and frequency we can control, the result is also now has an amplitude and frequency which is slightly better than the audio signal which we started off with. Right? And therefore this result of the modulation process is now much easier to transmit and with much lower losses. Right? Now at the receiving end, so let's say for example we have modulated, the mobile phone picks up your voice, modulates it and transmits it. It goes through all these towers, it goes through the communication satellite, it reaches the other person. And at the other end, the transmission towers will then move through and finally give it to the other mobile, right? So the other person who's also holding the mobile and who's also listening and talking is now going to receive this modulated signal or the high frequency signal. Now at this receiving end, the audio signal has to be extracted, the reverse process. Right? In the first case, we had mixed the audio signal with a high frequency signal. Now we are extracting the audio signal from the high frequency mixed signal. And we are now, this process, this reverse process is called demodulation. So at the sending end, we had modulated it. Now at the receiving end, we are demodulating it. Now it's important to understand that modulation processes and demodulation techniques, especially in these modern times, are fairly complex, right? But they are also very accurate. And that is one of the reasons why mobile communications have become so much clearer, right? If you go back around 20 years to when mobile phones first began to appear, mobile communications was actually quite glitchy. Quite often, the voice would disappear. So you're talking to somebody and you won't hear that person for, let's say, a few minutes. Or sometimes calls would be dropped. There were all kinds of problems. Now, mobile communications have become much better. Much, much better. Even if you're talking to somebody in another country. So, this means that all these techniques are now much more reliable. Right? So with this, let's establish a few definitions. Now, this audio signal from the conversation, which we are now trying to transmit, is called the modulation signal. And this is fed to the modulation process. So it is the input to the modulation process. Right? We call it the modulation signal. That's just a definition. Now, the high frequency signal with which we are mixing this audio signal is called as the carrier signal. So it is also an input to the modulation process because we are mixing it and feeding it to the modulation process. Right? Or rather, the modulation process is taking these two signals as an input and mixing them. Now, the carrier signal is called so because it carries the audio signal. Right? It pretty much carries. Again, like I said, the details will come soon and I won't even go into that many details. But basically, it forms a strong controlled base whose amplitude and frequency can be controlled, and on this base, our audio signal now rides. Right? That's what's happening. That's why it's called a carrier. So let's now give an example, a non-engineering example, which is similar to modulation. So for example, let's talk about human transportation. The way we humans move from place to place, right? We always have to move for whatever reason, for recreation, for work, for essentials, we have to move. Now, when we need to move from one place to the other, we would obviously like to choose the simplest method. So for example, the simplest way to move, and especially over a short distance, is just to simply walk, right? If you can walk, it's always the easiest because it costs you nothing and also it is healthy and it's the easiest. There's nothing you need to do. If the distances are longer, so for example, if by walking it will take you 15-20 minutes, we might consider riding a bicycle because it's also healthy, it's good for the environment, and it is cheap. It doesn't cost any gasoline, it doesn't cost any petrol or diesel or anything else. It's good for the environment and it's cheap. If it is very long distance, much greater distances, let's say for example 10 or 15 kilometers, we might consider taking public transportation or we might just drive, whichever is your preference, right? If you don't like to drive, you can take public transportation. If you prefer to have your own car, then maybe just drive, whichever is your preference. If the distance becomes thousands of kilometers, right, hundreds or maybe even thousands, in that case, you might have to use either a high-speed train if it's a few hundred kilometers, or if it's a few thousand kilometers, maybe the only option is to fly, right? Especially if you're crossing in the ocean, there is no way you can actually take a train, you have to fly. Now, in all these cases, the human is the one who wishes to move, right? The human can be said to be equal to the modulation signal because it is this human that wants to move in the same way that the modulation signal or the audio signal was to be transmitted. The carrier signal is the mode of transport, right? Because the human wishes to move and the human is using a machine. In the first case, the human was moving on his own. In all other cases, the human is using a machine. So, the reason is simple. Humans have limited energy, have limited speed, and have limited capacity. Some people like to walk, some people like to ride to bicycle. I know people who actually ride bicycle for tens of kilometers, right? And there are certain people who don't like to walk at all. Anything more than 5 minutes is too much. So according to your ability, you can choose which machine you want to take. So therefore, in all these cases, we have the ability to choose our mode of transport. This mode of transport enables us to move at different speeds. And it also allows us to conserve our own energy because if we keep walking and bicycling everywhere, we may have no energy to work, because after all, we must work. So therefore, in all these cases, this is similar to what we talked about communication. In order to transmit a signal, we used a carrier signal, high frequency carrier signal. And this high frequency carrier signal, when mixed with the audio signal, resulted in a signal that was easier to transmit. In exactly the same way, when humans use a machine, it becomes easier to move, and therefore it becomes easier to run, to go about our daily lives. Right? So this is a very, very, very basic overview of communication and the process of modulation. Again, very basic. I've not gone into any details. It'll come soon in the next few lectures. But the idea is to ease the process of understanding modulation. So if you have any doubts, please do post in the Q&A forum, or I will see you in the next lecture where we will get into some more details. Thank you so much for listening, and goodbye for now.